lesson we study conductors in electrostatic equilibrium. So this topic is essential for understanding electric fields, shielding and charge distribution. So this is another topic also in electric forces and fields. Yeah. So when we are talking about a conductor in electrostatic equilibrium, this is a conductor in which electric charges are at rest and there is no net motion of charge. Here, charges have finished moving, but the system is stable. Then electric forces inside the conductor balance what? Balance out. So, as you can see, like from the drawing that that's appearing on the screen there. So you'll find that for electrostatic, like a conductor in electrostatic equilibrium, as you can see on the diagram there is down the diagrams, you'll see that electric field 0 inside the conductor. The electric field is what? Is 0. All excess charges is on the what? On the surface. Then the other one is charges accumulate at sharp points. So at sharp points, that's where charges accumulate on the third diagram. So that is what we are talking about when we are talking about a conductor in electrostatic equilibrium. So a simple analog is like a water in a container becomes still. Once it stops moving, the system is in equilibrium. The same idea applies to the charges. So the example that we are trying to give here is the water in a container. When you try to put a water in the container, then you put the container at a level surface. So you find that the water is just going to be what? To be still. So that is just it applies to what? To the charges also, whereby the water is not moving. There is no flowing of water. Same applies to charges. When the charges have finished moving, the system is stable. Then the electric forces inside the conductor balance what? Balance out. At the end, the electric field inside this conductor is 0. So in the exam you'll be asked, so as you can see, inside an electrostatic conductor, the electric field is 0. No electric field inside. Also, all excess charge are on the what? On the surface. Then more charges accumulate at the what? At the sharp points. So these are the key points that you should know in electrostatic equilibrium. So these topics, they don't involve calculation that much. It's just mostly concepts. Yeah. So these are the diagram that I was showing. So everywhere inside the conductor, electric field inside is 0. All excess charge on the surface. So it's just the same thing. Yeah. Now there is one concept that you should know. And this concept is students usually often confuse charges moving and charges arranged but stationary. So when you are talking about electrostatic equilibrium, it does not mean that there are no charges. It just means that charges are not accelerating or drifting. So you are getting the point there. It doesn't mean when the bucket of water is sitting there is no water inside. It's just that there is no flowing of water inside that bucket. So same applies to the what? To the charges. And the key exam idea that I'll give you is, if charges were moving, the conductor would not be in electrostatic equilibrium. So that's a concept clarification that you should know in electrostatic equilibrium. Now, a conductor in electrostatic equilibrium has 4 fundamental properties. So that's where also they are going to be asking you questions in the exam. The fundamental properties of what? Of the electrostatic equilibrium. So the first one is a conductor in the first property is the electric field is 0 everywhere inside the conducting material. So inside the conducting material, the electric field is what? Is 0. That's what we are talking about. If an electric field existed inside, free charges would move, equilibrium would be broken. That is if there was electric field inside. But electric field inside what? Is 0. And this is a direct exam statement. The second property is any excess charge on an isolated conductor resides entirely on what? On its surface. any excess charge resides on what? On its surface. So like charges repel and charges move as far as apart as possible. So if they are like charges, they'll try to move what? They'll try to move apart. Try to see this diagram. All these are positive charges. So they'll try to move what? Apart, because they are what? They are repelling. Also, no excess charge is found inside the conductor. This explains electrostatic shielding. So that's all about the second property. Let's go to the third property. The third property is electric field just outside a charged conductor is perpendicular to the what? To the surface. Now, the electric field, now we are not talking about the inside, but now the outside of a charged conductor is perpendicular to the what? To the surface. If the field had a parallel component, charges would move along the what? Along the surface. So equilibrium there would have been what? Would have been disturbed. Therefore, electric field lines meet the surface at 90 degrees. The property is commonly tested in what? In field line sketches. The fourth property, that was the third property, which is if the field had a parallel component, charges would move along the surface. So the third property, the electric field just outside the charged conductor is perpendicular to the what? To the surface. The fourth property is on an irregularly shaped conductor, charge accumulates where the radius of curvature is smallest. So this just means at sharp points it collects what? More charges, and rounded regions collect less charge. So electric field is strongest at sharp points and weakest on smooth flat surfaces. This explains phenomena like corona discharge and lightning rods. Now, what the mathematical expression, the electric field just outside the conductor is usually given by electric field is equal to over permittivity. Now that one on top, the E means electric field just outside the surface. Then this one on top, this is the surface charge density over the permittivity of free space. This charge density is highest at sharp points. Therefore, electric field sharp is greater than electric field smooth. Yeah. So that's the mathematical expression of what? Of electric field in terms of what? The conductor. So whereby the E is the electric field, that one on top is the surface charge density, then down there is the permittivity of what? Of space. So here are the few worked examples that you can look on. Yeah. So this subtopic is all about just concepts, not a lot of calculations. No. So the only calculation that we'll be finding is the electric field inside is what? Is 0. So check out the examples. For example, the first example, a hollow metal sphere carries excess charge. What is the electric field at a point inside the metal? The answer is 0. The reason is what? The conductor is what? Is in electrostatic equilibrium. Another one is an irregular conductor has both sharp and smooth regions. Where is the electric field strongest? So as I said earlier, electric field is always strong at what? At sharp points. From that one was just an interpretation to add on what we have learned. Conductors shield their interior from what? From electric fields. Also, charges naturally arrange themselves to maintain what? Equilibrium. For example, if they are all positive, they will try to repel. At the end, they form what? They will arrange themselves. Also, geometry of a conductor affects what? Electric field strength. So the conclusion there is strong electric fields occur where charge density is what? Is high. So I'm just going to give you practice question that you will try in case they come in the exams, multiple choice, what and what. Yeah, so you can even write them somewhere. So the first one is what is the electric field inside the conductor in electrostatic equilibrium? The answer is what? The answer is 0. The second one is where does excess charge resides on an isolated conductor? On the surface only. The third one, why is the electric field perpendicular to the conductor surface? To prevent what? Charge motion along the surface. The fourth one is why does charge accumulate at sharp points? Because the radius of curvature is smallest, increasing the what? The surface charge density. So that's the end of the video, guys. So just to give you the exam tips, There are the exam tips you're going to be using. Always state the electric field inside is 0 clearly. Do not say charge is evenly distributed on irregular conductors. Use keywords like surface, perpendicular, radius of curvature, and so on. So that's the end of the video, guys. Don't forget to like and subscribe. Also, share the videos to your friend or your classmates and more, to help other students to also get to see the video. So thank you for watching and God bless you.